So this is paper 1 of the higher level year 12 mid-course 2022. Calculators are not allowed in paper 1, so just bear in mind that when you are using G, which is normally 9.81, you're expected to use 10 for ease of calculations. Question 1, we're looking for one scalar and two vectors. The answer is D. Power is scalar and momentum and velocity are vectors. Question 2, we're also looking for scalars and vectors. It says how many scalar quantities are in this list? Well, acceleration is a vector. It has direction as well as magnitude. Energy, mass, and temperature are scalar. So it is 3, which is C. Question 3, we're looking for the gravitational potential energy of an object that is moving a vertical height of 8 meters against gravity, which is mgh. So we're actually given the weight, which is mg alone, and then we multiply that by the height. So we have 6.1 times 10 to the 2 multiplied by 8.0. If I were to do a quick calculation of that, I would do 6.1 times 8, and I come out with 48.8, which is 49, but I've got the extra times 10 to the 2, which is the same as saying 4.9 times 10 to the 3, so B, 4.9 kilojoules. Question 4, what is the percentage uncertainty of the density of the cube? And we're given mass and length. So density is mass divided by volume, which is the same as saying mass divided by length times length times length, because it's a cube, so we have the same value 3 times. So if we're looking for the percentage uncertainty in density, it's the same as saying the percentage uncertainty in m plus, because we've got a divide sign, 3 lots, because we've got 1, 2, 3 L's of the percentage uncertainty of the length. So we have percentage uncertainty of the mass is 8 plus 3 lots of the percentage uncertainty of L, which is 4, so it's 3 times 4. So we end up with 8 plus 12, 20%. The answer is D. Question 5. A ball undergoes an elastic collision with a vertical wall. Which of the following is equal to 0? Right, so automatically impulse is force times distance. So, force times time. So if a ball is undergoing a collision, the collision is going to last a certain amount of time. So the time is anything but 0, so it's not that one. The rate of change of linear momentum. So the rate of change of linear momentum is the acceleration, and as we're getting a change of speed, there is a change of velocity, there is an acceleration, so it's not C. And then we come to B. So the magnitude of the change of linear momentum, so the size of the change of the momentum. So what we have is moving towards the wall, you could say we have a positive momentum, and moving away from the wall, we're moving with a negative momentum. So if we were to do the change of momentum, it would be final minus initial, which is minus 2p. So we've got a negative 2 momentums, and the magnitude is 2, so it's not b. So it is a, but let's just check why. The reason why is it's saying the change of the magnitude, that's not the same as b. So moving forwards, we have, say, a positive momentum, then it hits the wall, but we want the magnitude. So we simply have p moving forwards. Then when it's coming away from the wall, we have a modulus negative momentum. So again, that's just p. So p minus p is 0, so it's A.